All right, so what we're going to start with is section P.1, P.2. It is the very bottom section, which is converting decimals and scientific notation, just because we didn't get to anything like that last time. So we'll finish that up, and the plan is to do P3 and P4 today. Those are a little bit shorter than the ones that we did earlier this week. Okay. So scientific notation in standard form, it means you have some number times 10 to a power. 10 to a power just means, hey, there's this decimal and you're going to move it left or right this many places. So this exponent tells you how far to move your decimal point left or right. You're going to move it right if it's a positive number, or left if it's a negative number. Okay, so if you had like 3 times 10 to the third, you're going to move the original decimal place from after the 3 places to the right because the exponent was a 3.
Can you say that again?
Absolutely. If we had, actually, let's put a decimal in there, 3.1 times 10 to the third. This means move your decimal 3 places to the right. So if we have 3.1, we move it 1, 2, 3 places. And any spot that is empty, I'm going to zoom in here, you put a 0 in there. So 3.1 times 10 to the third means 3100. You'll see this in a lot of science classes. They want your answers in scientific notation. Scientific notation is easiest when you have super large or super small numbers so that you can have them on the same scale. Okay. Your calculators show scientific notation a little bit differently. If you have an extremely large or an extremely small number, for example, if your calculator showed you 3.78 E24, again, if that's on a calculator, the E stands for times 10 to the 24th power. This is equivalent to that. So not only, like I said, are we learning different math concepts, we're also learning how the heck to use these calculators and what it means when they spit these random things out. Okay. All right. Now, what's really important about scientific notation is that this number that you're multiplying by 10 to a power, for it to be in standard form, it has to be a number between 1 and 10 and is allowed to equal 1, meaning it has to be a single digit number, point something. You don't ever want 0 point something. You don't want 31 point something. You want a single digit number, point whatever comes after it. Okay? So let's go ahead and rewrite these. For number 24, right now, our decimal is after that number. Okay, it's at the end of the number. Where would I have to put the decimal to change that to scientific notation? I want something times 10 to some power. Where would I put my decimal? Would it be there, or there, or there, or there? Which one of those would be the place where I'm putting the decimal to make it a number that is between 1 and 10?
On the 4.
Right. You'd want the decimal behind the 4. So we can write this as 4.21. And how many places did we have to move it? 1, 2, 3, 4, 5. 4.21 times 10 to the 5th. Because I moved it right 5 places, I made it a bigger number. That's why it's 2 times 10 to the 5th. Okay? That's it. What's great is if you ever want to check, in your calculator, type in 4.21 times 10 exponent 5. Does it give you that number? You can always use that as a check. These worksheets are due on Monday. Do you know how to type it in? Are we good there? To get an exponent, you need that little caret button. Okay. Awesome. All right, what about number 5? Or 25. Something times 10 to some power. Where would I have to put the decimal? Right now, it's after the 10. Where do I want it to be a number between 1 and 10?
Between 1 and 0?
Yeah. So we want this to be 1.0, and I had to move it 1 spot. 1.0 times 10 to the 1st. Okay? Now, what if we're starting with a small number? We already see that the decimal is here. It is clearly marked. Where do we have to put the decimal to make it a number between 1 and 10? Between 5 and 6. There we go. Because if we put it between the 6 and the 1, it would be 56.1, and that's too big. Now, if we're starting with 5.61, and I have to move to get to that red dot, I had to move 1, 2, 3, 4 places. But did I go from 5.61 to a bigger number or a smaller number? Smaller. So because I had to move left, I'm going to make that a negative exponent. That negative exponent means your number's getting smaller from this starting point. Does that make sense? Okay. That is the general gist of scientific notation. Any questions? All right, completely different topic. Polynomials. Like I said, the first preliminary chapter jumps quite a bit. I feel like it's like that with most math classes. So we're going to work on polynomial vocabulary. We're going to work with adding, subtracting, multiplying, and then we have special product formulas that we're going to use as well. Okay? So, some polynomial vocabulary. A monomial contains one term. It could be a letter. Oops. It could be a letter, a number, or the product of letters and numbers. Okay, so a monomial can be a letter, a number, or the product of letters and numbers. It means there's no plus or minus signs in between different terms. It's just one chunk. A coefficient is a constant, meaning a number, in front of a variable. It's a number in front of a letter. For example, if we have 3x, 3 is the coefficient. Also, if you want highlighters, they're in here as well. You are more than welcome to borrow whatever you need. The degree of a polynomial is the largest exponent in that polynomial. So if I have 2x to the third minus 5x to the fourth plus, 9x minus 7. What is our largest exponent? 4 would be our degree, because that's the biggest exponent up there. In order for something to be a polynomial, you can only have positive, real, integer exponents. For it to be a polynomial, positive, real, integer exponents. Please remember, when you're adding and subtracting polynomials together, you are not changing exponents. You're just combining the pieces that have the exact exponent. Okay? So, finding sum and difference of polynomials. If I am adding these together, let's start with sum. Sum means you're adding them together. We could add them horizontally or vertically. I am kind of ridiculous when it comes to my organization, so I prefer lining things up vertically. So let's start with my highest exponent. What is my highest exponent of all of these pieces? Okay, so starting with the left side, we have a negative 4x to the third. Then we're going to keep working down to the lower exponents. So plus 5x to the second plus 7x minus 2. Okay, sum means we are adding two equations or things together. From that second part, what I'm going to try to do is line up the x to the thirds with the x to the thirds, the x to the seconds with the x to the seconds, the x's with the x's, and the numbers or constants with constants. So 6x to the third is going to go here. Minus 2x to the second goes there. Minus 8x minus 5. And then add vertically. So what is negative 4 plus 6? 2, and then we keep that x to the third. Again, we are only allowed to add or subtract things that have the exact variable and exponent. So 5x to the second minus 2x to the second is, it's a positive 3x to the second. 7x and a negative 8x. Negative x or negative 1x. I'm not picky with either of those. That's fine. Again, you could put the 1 in there. Not necessary. Negative 2 and a negative 5. Negative 7. How many of you struggle with negatives sometimes when you're adding and or subtracting? Okay, so when we're adding, this is saying, if you're starting at ground level, it's telling you to start down 2 floors and then go down 5 more. You're down 7 floors. Okay? Okay? Subtraction is a bit different though. If we're finding the difference between them. I don't want any. So we're going to keep the top one and subtract the second one. So negative 4x to the third plus 5x squared plus 7x minus 2. But we are subtracting that whole bottom row. It gets confusing if we have to constantly remember to subtract, so what we could do instead is multiply that entire bottom row by a -1 and then add. Subtraction is the same thing as adding the opposite of what's already there. So subtraction equals adding opposite. Okay. So if I put plus, this would be a negative 6x to the third. A positive 2x to the second. A positive 8x. And a positive 5. You are changing the signs of the entire polynomial expression that you are subtracting. So here, again, when we look, every single sign was the opposite of what it was originally. And then we can add like terms together. Okay? So what is a negative 4x to the third and a negative 6x to the third? Negative 10x to the third, good. 5x squared plus 2x squared?
7x squared.
Positive 7x squared, good. 7x and 8x? Positive 15x. Negative 2 and a positive 5? Positive 3. Okay? Got it? Any questions? Okay? So again, when we are adding or subtracting, exponents do not change. You're grouping things together that already match. Multiplying is completely different. When we are multiplying each term in our first piece by each term in our second piece. Think about it as distributing a lot. So when we're multiplying here, we're multiplying 4x to the third by this whole thing. So 4x to the third times 3x squared minus 5x plus 7. We're going to do this one piece at a time. 4x to the third times 3x squared. What's 4 times 3? 12. X to the third means there's 3 x's being multiplied. X to the second means there's 2 x's being multiplied. So when we multiply them all together, that becomes x to the 5th, because you're going to add those exponents.
So you'll automatically add them?
Every time you are multiplying variables, you add their exponents if they're the same letter. You put them right next to one another. So if it was like x times y, it's whatever the number was, xy. Most of the time, we put them in alphabetical order. So now we're going to do 4x to the third times negative 5x. So 4 times negative 5, negative 20. And then what about those x's? X to the 4th. Because there's 3 and then 1. And then 4x to the third times 7. 28, x to the? Good. That's it. Those exponents don't match one another, so we don't need to do anything else. Leave it as it is. Okay? What if we have more stuff? This means, and I'm going to write it above, 4x to the second plus 3x times x to the second plus 2x minus 3. I'm going to start with the most basic of ways to explain how to multiply this. And then I can show you the more complicated way, but I think the basic way might make the most sense. Okay? What we're doing is taking each piece from in here and multiplying it by that second set of parentheses. So x squared plus 2x minus 3. And then I take that 3x and also multiply it by that second set of parentheses. Yeah? If there were 4 terms in that first set, I would have 4 different things being distributed to that second set of parentheses. I'll pause there for a second, just so you guys can get caught up with writing. Okay. 4x to the second times x to the second. 4x to the fourth. There's a whole box of highlighters. You can choose your color. 4x to the second times 2x. Positive 8x to the third. 4x to the second times a negative 3. Negative 12x to the second. So far, so good? Kind of making sense? All right. Now we have to distribute that 3x. Want to post-it note?
Yeah.
Back on my desk, on the right side, there's a whole, keep going, there you go. There's a whole variety of them.
I'm just gonna grab them.
Totally fine. All right, 3x times x squared. 3x to the third, good. 3x times 2x. You were close, 6x to the second, good. And then? Negative 9x. But we're not done yet. We have to combine like terms. Things that have the exact same exponent need to be combined together. So 4x to the fourth is there. Let's look at those x to the thirds. What you hopefully notice is that I am also taking the sign in front of those numbers with it, because that's how you're going to combine. So 8x to the third and 3x to the third, plus 11x to the third, good. Negative 12x to the second and a positive 6x to the second. Negative 6x to the second, and then we have minus 9x. Does that make sense? Kind of, sort of, maybe. Okay. It's a lot of steps, but I think each of the individual steps make sense. It's just a lot to keep organized. Okay. Now, I'm going to show you a different way that I just do it in my head and put them together. But I'm going to wait a second until you write it all down, because obviously I don't have room to erase and go back. Let me know when you're ready. You good? Okay. So, for the sake of this, we're still going to get the same answer. In my head, I would normally start with whatever this first term is and multiply it by everything here without actually writing it in parentheses. So 4x squared times x squared is 4x to the fourth. 4x squared times 2x is a positive 8x to the third. And 4x squared times negative 3 is a negative 12x squared. We okay there? Then I'm going to take the 3x and multiply it by the o's over here. And when I do that, I'm going to line it up in the appropriate exponent. 3x times x squared is a 3x to the third, positive. 3x times 2x is a positive 6x to the second. And 3x times negative 3 is a negative 9x. Now, 4x to the fourth plus 11x to the third minus 6x squared minus 9x. It is up to you how much work you want to show and which method you'd rather do. You get partial credit on tests, so, and worksheets and that kind of stuff, okay? Which way do you prefer?
That second one.
Second one? Anybody prefer the first? Totally fine. And this is why I give you some options. End result is the same, it's just the process might take a little longer to get through. Still doing okay? Okay. Next page, number 4. I want you to try to multiply those, but one of the things I need you to be sure of, make sure you multiply it by that negative 1, okay? I want you to show your steps, however method you want to use. And then I want you to check your answer. And the answer is up there that you should get, as long as I did that right.
Wait, we're multiplying? Okay.
Yes, you're multiplying. Great question. Because there's no sign in between the two sets of parentheses, that's how you know you're multiplying.
Mm-hmm.
So take that 2x and multiply it by x minus 1, and then take your 3 and multiply that by x minus 1. And then combine your like terms. And for that answer, that 1 in front of the x is optional. You don't need to have that 1 there, you could just have it as an x. If you were able to get that, I want you to try number 5.
I really thought I was doing something there. I look up and it's like not even. I got that one.
Okay. You forgot to do, you did those times that.
Mm-hmm.
You forgot to do these multiplied and these multiplied.
Oh. Okay.
Okay. Yep. Make sense?
Mm-hmm.
And then the last ones, obviously.
Okay.
How'd you do?
I don't know. I know it's just somewhere.
All right, 4 or 5 or both?
On 5.
Okay.
I got number 4.
All right, let's see. So if we multiply 3x by that, we get 12x to the second. And then minus 18x, right? And then if we multiply negative 5,
Oh yeah, I see where it is.
and then we get negative 20x, negative 5 times negative 6 is a positive 30.
Wait, how did you get 30?
Because negative 5 times negative 6.
Oh, okay. Okay.
Okay,
Yeah, I did it.
sweet. Anybody need the steps for number 4? And by need, I mean, does anybody want the steps for number 4?
Mm-hmm.
No? Are you sure? Okay. All right. Still doing okay? All right. Love to see it. Squaring binomials. Squaring binomials drives me nuts because we just went over exponent rules, and everyone's like, oh, I know what to do with an exponent on the outside. You just distribute it to every piece inside. That's true if there's no plus or minus inside. If there is a plus or minus inside, we have to write it twice. So, a plus b inside parentheses to the second power means a plus b times a plus b. And when you distribute a times a, you get a squared. A times b, you get ab. B times a, you get ba. And b times b, you get b squared. Now, it doesn't matter what order AB or BA is in. It's saying that A and B are being multiplied together, and there's 2 of them. That's why it says 2AB, because you can see that there are 2 of those things being multiplied together.
So it doesn't matter.
Nope. You do not have to memorize this formula, though. This is one of the ones you do not have to memorize. You could just write it out and distribute, just like we did before. So anytime you see this exponent of 2 on some kind of polynomial or binomial, binomial means there's 2 parts inside those parentheses, write it twice. Okay. Then we can do exactly what we did before. 2x times that stuff on the right is 4x to the second plus 6x. And 3 times that stuff on the right is 6x plus 9. What you'll notice is that there's 2 of the exact same thing. So that's how we get 4x squared plus 12x plus 9. Okay? Yes? Okay. What's kind of cool, if we have the difference of squares, your middle term cancels out. Difference of squares means whatever you have here, it's the same, but a different middle sign. So if it was like 5x minus 20, multiplying difference of squares would be 5x plus 20. One would be plus, one would be minus, but exact same numbers. Okay? So let's see what happens. If we do 3x times that stuff on the right we get 9x squared minus 12x. And then 4 times that stuff on the right gives us a positive 12x minus 16. So our final answer is 9x squared minus 16, because a positive and a negative 12x gives you 0. Go ahead and try number 8. And then check your answer when you get a minute. How'd you do with 8? Cool. Anybody have questions on 7 or 8?
I'm getting the numbers, but I forgot to put the letters down.
Gotcha.
I don't know where the letters go. I got the numbers, I think. I think I'm doing it. I want to hope I'm doing it.
All right, let's see.
Yep, because there's 2 A's in the second. And then here, because of that times that, it's an A and B, so AB.
Okay.
But that would have been negative.
Oh.
Because when you do it, you take the sign that's in front as well.
Okay.
And then here, that times that is an A and a B. And then this times this is a B and a B.
Okay.
So it goes in its own little category. There you go. Okay. All right, are we good with multiplying? That made sense? Cool, let's do the opposite. Let's factor. Just gonna scroll to see how many examples there are in this section. Not a terrible amount. All right.
What's the answer?
Yep, you could also write that as B, the second power instead.
Okay.
Alrighty. So, GCF, greatest common factor. Basically, anytime you have stuff and it asks you to factor, what you want to try to do is take out what they all have in common. Okay? It has to be from all of the terms. They all have this in common. It could be a number. It could also be letters. So let's start with just numbers. What do 16 and 24 have in common? 8 goes into both of them. 8 is the largest of the numbers that goes into both. So if we took out an 8, okay, now let's look at the letters. This has 3 X's. This has 2. They both have at least 2 X's. So we can take out an 8X to the second. To find what's left over, sorry if I make you rewrite this. I'm moving this down a little bit. Because if we divide this by 8x to the second and this by 8x to the second, that's what goes in here. So what is 16 divided by 8?
2.
And x to the third divided by x to the second? How many x's are left over? 1. And then 24 divided by 8? Positive 3, good. And then x to the second over x to the second, there are no x's left over. That is how you factor out what they have in common. Sometimes you can factor out multiple times. If we had started by taking out 2, you'd have to take out 2 again, and then 2 again. It's okay if you have to do it multiple times to make it easier. Totally fine, okay? Number 2, what do all 3 of those have in common? 5, and what else?
2. Or
Letters.
X.
X. 5 and an X. So if we divide every single one of those pieces by 5x, what do we get first?
Well, like 1 bar like X.
Yep, 1 and then x to the third. Okay. What about that middle term?
4.
4x, good. And then?
5X. Or no X, because the X.
Just 5, good. Is there anybody that's a little unsure of any part of that? No? Okay. Well, this looks like a cluster. You see how there's this plus sign in between these two sets of things? What do you see that's the same?
X minus 3.
X minus 3 is exactly the same. If we take out that x minus 3, what's left over in this first part? Good. And then over here, a positive 7. That is technically factor by grouping.
Wow.
So if you see, even if it's a messy set of stuff, that they have the exact same parentheses in common, you can take the whole set of parentheses out and leave what's left over. Yes? Still okay? Okay. Love that. All right, when we have 3 things that we are trying to factor, and there is no number in front of x squared, it's just a 1. What we're trying to do is find 2 numbers that add to 8 and multiply to get 15. 2 numbers that add to get 8 and multiply to get 15. Yep. Exactly. X plus 3, x plus 5 is your answer. Because 3 times 5 equals 15, and 3 plus 5 equals 8. Now, if you didn't know that right away, what you could do instead is list the factors of 15. Bless you. 1 and 15, 3 and 5. Do you agree? Those are the only things that multiply to get 15. Yes. When this is positive, it means you're going to have the same sign for both of your factors. And the only way to add 2 numbers together to get to a positive is if they're both positive. So that's how we know it's a positive 3 and a positive 5. Does that kind of make sense? Yeah, maybe. All right. Let's try the same thing over here for number 5. What adds to get -6 and multiplies to get a -16? So what we get?
8, possibly 2.
-8, +2. And if you didn't know that right away, you know it's 1 and 16, 4 and 4. Actually, I could do 2 and 8 next would probably make sense. And then 4 and 4. Because it's a negative, it means they are opposite signs. The only way you can multiply two numbers together to get a negative is if one's negative, one's positive. So the only way that would work is if it was a -8 and a +2. So x minus 8, x plus 2. I don't care if the x plus 2 is first and the x minus 8 is second, as long as what's in the parentheses is the same. The order does not matter. Again, the only time we can do that is when this has a 1 in front of the x squared. Okay? And you can always work backwards and check to make sure that when you multiply x minus 8 and x plus 2, that gives you what we started with. Walk me through number 6. An explanation of what we should do. What are we trying to look for? How did we do number 4? What did we look at?
What factors put into both?
Okay, so what do you mean by that?
Are like the I don't know what it's called.
What am I looking at this for?
Signs?
Okay. I'm looking for those signs to add to this. What am I looking at this for? Multiply. When it's a positive for the multiplication, it means they are the same sign. What are the only numbers that multiply to get 2?
2 and 1.
Yep. Is there any way to add 1 and 2 together to get 1? But they have to be the same sign. This is kind of a trick question. You can't. It's not factorable. This one you can't factor. We have other ways of solving that we'll do in other sections for ones that are not factorable. Okay?
So much different.
Still okay? Kinda. Maybe. So we've got some formulas here. If you have something squared minus something squared, that is called difference of squares. It means you're going to have the same thing in both sets of parentheses, but one's going to be a plus, one's going to be a minus. This, you can just solve normally. You don't have to memorize this formula. Not super important for that second one. Or that third one, honestly. Not super important. What is really important to write down are these two. And probably this one. Okay? So highlight it. Do something with it so you know that those three are really important. Because as I said, you will get a cheat sheet on your tests. One sheet, front and back, that you can write whatever you want on it, as long as it's handwritten. I'd probably write these 3 things down. Maybe an example of those 3 things.
keep going backwards, I have so much.
It's okay.
I try to go so fast.
Yeah. No.
Okay, so again, just star, highlight, asterisk, do something so you know those three are really important ones to remember. Okay, so some examples of them. I have three terms. Do those three terms have anything in common between all of them?
Oh, wait.
All three terms, do they have anything in common for all three? The first one doesn't have one. So there's two things that have stuff in common, but not all three. So now that we have all three separate, nothing in common, and this has a coefficient of 1, we can go straight into the add, multiply thing. Two numbers that multiply to get 25 but add to get 10. 5 and 5. So you can write that as x plus 5 times x plus 5. Or you can write that as x plus 5 to the second power because it's showing up twice. So the next one has a number in front. But this is a special pattern. Do you see any relationship between 16 being something squared and 8 being something added? Yikes. Yeah, 4 times 4 is 16, but 4 plus 4 is 8. We just need to make those 4's negatives. Or the 1's negatives. Let me show you what I mean. 4x minus 1 and 4x minus 1. Factoring is all about pattern recognition. Reason being, 4 times 4, or 4x times 4x is 16x squared. We okay there. Negative 1 times negative 1 is a positive 1. Negative 1 times 4x is a negative 4x. 4x times negative 1 is also a negative 4x, and that's how we get negative 8x. Again, that's just a special pattern. Number 9 should be a little easier, I hope. Do x squared and negative 4 have anything in common? No. But there's only two pieces and there's a minus sign between them. That tells me one's going to be plus, one's going to be minus because my middle terms cancel. Basically, you're asking yourself, what multiplies to get negative 4 but adds to 0?
Wait.
What multiplies to get negative 4 but adds to 0? Yep. 2 and negative 2. This is the difference of squares. Since 4 is a perfect square and so is x squared, we can split it into the same thing, different middle sign. 10 follows the same pattern. Is there anything that 25x squared and negative 49 have in common from both of them? Can you take the same number out of both? This isn't a trick question, I promise. No, you can't. But they are both perfect squares. So we're going to have the same thing, but different middle signs. What times itself gives you 25x squared? 5x. And what times itself gives you 49? 7 times 7. And your middle terms cancel out because one would be plus, one would be minus. Number 11, any idea for this one? This one's kind of mean. I'll give you a hint. Okay, 4 and negative 4. But what's going to go in the first terms?
X squared.
Yeah, x squared and x squared. But we're not done with this one because I'm rude. What can we break down further?
4.
Which one? There's 2 of them. Only the minus one. Because that's the only one that does difference of squares again. So x squared plus 4, it's a plus sign. We can't do that. There's nothing that multiplies to get a positive 4 and cancels out the middle terms. But x squared minus 4 could be x plus 2 and x minus 2. It is always difference of squares. Yeah? Okay. Is this it? Ugh. Hold on. Sorry, I'm just looking ahead to see. Oh, I'm mean. Okay. These, because it has an x to the third and a number, we're going to use the sum or difference of cubes. Again, this is a really important one to have on a formula sheet somewhere as a reference. Okay. Perfect cubes. X to the third is like x to the third. 64 is 4 to the third. So if we follow this pattern, this would be x minus 4, because this sign is the same. Okay. And then x to the second, opposite sign, the first term times the last term, and the last term squared. I'll say that again. And I'm also going to show it with colors. So it was my first term that I could raise to the third power, squared. Both of my terms multiplied together with the opposite sign from over here. And my last term that could have been raised to the third power times itself. Anybody need that one more time? Just to try to, okay, absolutely. So for this, again, we're trying to figure out what times itself 3 times gives me x to the third. The only thing that does that is x. Also, what times itself 3 times gives me 64? 4. Once I find that, I'm filling into this general formula. I'm taking, and I'm going to use like this little thing. I'm taking this that was raised to the third power and putting it in the first part of my parenthesis. I'm taking the same sign and then this in the second part, okay? I'm taking my first part squared. That first part times itself. Opposite middle sign. First part times second part goes right there. And this part times itself goes there. Okay? We're going to try it again. That is true for cubes that are positive or negative. Okay? For 13, there's nothing that those have in common. This is 2x times 2x times 2x. 2 times 2 times 2 gives you 8. X times x times x gives you x to the third. 5 times 5 times 5 gives you 125. Now, we're following the same pattern that we just did in number 12. That first term, same sign, that second term. What is 2x times 2x? 4x squared. Opposite sign, 2x times 5? 10x. And then 5 times 5? Is 25. You'll have like one of those types of questions. What's special about this? This stuff in that second set, that like really large part, is not factorable. You can't break it down. It's just a special pattern. Yeah? Maybe? Kinda? Okay. I promise the next one's not as bad. How many terms are there in number 14? How many different things are being added or subtracted?
3, 4.
4. Do all of them have anything in common? No. What happens if I split it down the middle? Do the first two have anything in common?
They both have x to the power.
Yeah. They both have at least 2 x's, so x squared. If I take x squared out of them, what's left over? X and? X plus what?
Wait,
2.
so
All right, what about this stuff over here? Do the 3x and the 6 have anything in common?
3, 2.
Yeah, they have a positive 3 in common. So when you divide them both by 3, we get x plus 2. What do you notice here?
That they both have the same factors.
Yeah, they both have x plus 2, and x squared plus 3 is what's left over. That is factor by grouping. See if you can try that with 15. Four terms, split it right in half. Once you get past the first step, look up. Okay, I think most of you were able to get the first step. So when you split that in half, you are able to get that 3x to the second power is in those first two. So when you divide by 3x to the second power, you get 2x minus 1. Now, that right half started with a negative. Anytime it starts with a negative, you want to pull the negative out. Because when we pull the negative out, it allows us to get the same thing in both. Okay? So then we have 2x minus 1 times 3x squared minus 2. Yes, no, maybe so. Okay. Yeah? Okay. I know factoring can be a little tricky sometimes, but. All right. You won't have too many of these types of questions. Is it okay if we just do one of them? And then if you need more practice, okay. When we have a number in front, and there is nothing that all three of them have in common, we're gonna do a little factor by grouping, but we have to rearrange to make some stuff work nicely. What we're going to do is multiply our first and last term together. Okay? We are looking to find two numbers that multiply to get 42x to the second. We're looking for two things that multiply to get 42x to the second, and that adds to get 17x. So we want to figure out what times what equals 42 and what plus what equals 17. So let's find the factors of 42. 1 and 42. It definitely does not work. 2 and 21.
Emiliano Mendoza to the front office, please.
Still a no-go.
Emiliano Mendoza to the front office.
What about
Mayo-
3? 3 and 14. Oh, hey, look, we found a match. The only thing we still need there, they need x's. Because the only way we can get x squared is x times x, right?
Naila Martin to the front office, please.
All right, so we're going to keep the first part. We're going to keep the last part. And instead of having that plus 17x in there, we're going to replace it with a plus 3x and a plus 14x. It doesn't matter which one goes first. It'll still factor the same either way. And we can split down the middle, because now there's 4 parts. And it looks like what we just did. What do the first two have in common?
They have an X?
And? What number goes into 6 and 3? 3. So if I divide by 3x, we get 2x plus 1. All right, cool. What about this right-hand side? They have a positive 7 in common. When we divide by positive 7, we get 2x plus 1. What do you notice about those pieces? Uh-huh. So 2x plus 1 is in one set, and 3x plus 7 is in the other. That will work every single time. Okay? If you want, I can show you how to do 17, or we can be done.
Yeah.
Show it or done? Oh, okay. I was like, yeah, we're done. Do you guys have a class after this too? Even though I have a class coming in, you are more than welcome to stay and ask questions.
Okay.
Okay? Do you want an explanation as I go through this? Or do you want to try to follow along without the explanation to see if you understand? And then I can explain it. Okay. And then I can explain it after if you do want the step-by-step explanation.
Okay.
What am I doing here? There we go. Talk to me. Where did I lose you? Did I lose you? Somewhat,
The-
maybe.
The side numbers.
Okay. All you need to do, if you're not sure what the factors are, take your calculator, do 120 divided by 1. 120 divided by 2. 120 divided by 3. And keep going until you find your list.
Okay.
Okay? Obviously, the larger that this number on the side is, the more factors you're going to have. We're going to hopefully not use numbers quite that large just because I don't want to test how well you can multiply it. Like, I want to know if you actually know how to factor, like the general idea of it, not to try to throw you off with all this ridiculous stuff. Okay? All right.